In this project, we introduce a new wireless primitive called Ambient Backscatter that enables interactive devices that compute and communicate without any batteries. To create a visual sense of what we have set out to do, we created devices that have no batteries and yet can interact with users and communicate with other devices. Here the user initiates communications by swiping the touch sensor on the left device. The right device blinks an LED to confirm reception. The cool thing here is that neither of these devices have any batteries. Ambient Backscatter enables wireless communication by leveraging the signals all around us, instead of generating our own. Say two devices, Alice and Bob, need to communicate. Alice can send a message to Bob by either absorbing or reflecting signals from a nearby TV tower. So for example, Alice sends a 0-bit by absorbing all the incident TV signals and a 1-bit by reflecting these TV signals. Alice and Bob do not generate their own RF signals, and they use no batteries. Thus, Ambient Backscatter enables wireless communication out of thin air. Here we demonstrate an offline payment application. Each card has some onboard value. This battery-powered payment terminal reads and displays the initial value in card 100. Its initial balance is 110. Then, with no terminal present, touching a button on card number 209 transfer funds directly to card 100. The entire transaction is powered by ambient RF. Now we use the payment terminal to check the new balance on card 100. It is increased to 130. This is just one example of what we can enable by using existing wireless signals as both a source of power and a communication medium. Now imagine a world where everyday objects such as keys, wallets, and sunglasses are enabled with ambient backscatter tags. These tiny battery-free devices can leverage ambient Wi-Fi, TV, or cellular signals to communicate with each other and localize themselves. For example, if a person loses his keys, the couch can use ambient backscatter to communicate with the lost keys and alert the user. This technology will enable smart homes, smart cities, and an Internet of Things. Tiny ambient backscatter devices can also be embedded deeply into inaccessible sites, such as concrete walls, floors, or roofs. Since embedded devices have no battery, they last forever and require zero maintenance. Such tags can leverage ambient signals for sensing and communication and enable long-term home monitoring and industrial applications. Beyond these example applications, what we are doing is transforming existing ambient RF signals into a source of power and a communication medium. This new functionality can create opportunities in multiple application domains.